All right. Oh, I said it anyway. Dang it. Uh, so on that last video we looked at, we were finding the turning points and the relative min and max of a cubic as a degree 3. And I was saying that's because it was degree 2 times a degree 1. And it's degree 3. We just add the exponents. And so you wind up this thing with 2 humps. All right, hump there, hump there. This one, all right, it's got 1, 2, 3 humps. And so hopefully just from that, you can kind of make a prediction for the degree of the polynomial. All right. So this is degree 2, all right, because they're squaring a linear. So that's 2 plus this one, that's a degree 1. That makes 3 plus this one, that makes 4. So this one is a degree 4 polynomial. And it's got 3 humps, 1 less than that. All right, so let's get to work finding these critical points, these critical values. So I've almost got it typed in here. 0.5 x minus 2. I just need to do the 2x plus 3 squared. Zoom standard. All right, again, I'm going to change my window. -5 to 5 for the x values. Graph that. A lot better picture. Ooh, see how I'm missing some down here? I'm going to make my y minimum further down. My y minimum to -15. That way it goes down further. Yeah, that'll do it. All right, let's find that one first. So I'm going to go over there first. I was trying to make a guess for what it might be, but nope. I was thinking it might be a whole number there. I was paying attention to those x values. So calc menu, this one was a minimum because that's a lower spot. All right, our blinking dot is already to the left of it. Now we'll get it to go to the right of it. So we're just getting it to the right of that left hump. Oh, I could have guessed that actually. -1.5. All right, that's my turning point there. -1.5. And this is an E, so that is an x-intercept. All right, that is going to be an x-intercept there. And we are finding x-intercepts today. There's my dog. So the x-intercept occurs at -1.5. That's the first one. And we know that because it's the x value where the y value is 0. All right? It just so happens that it happens at a critical point, all right, or a turning point. Try to label this for you. Stay consistent with the way I'm teaching this stuff. All right, and that's also going to be a relative minimum at that spot, y value. All right, at that spot, that is an x-intercept. You can probably guess what it is. 0. Yeah, at 0, 0, this thing crosses through the origin. So we're looking for the x value where the y value is 0. So another x-intercept is at 0. But we need this critical point up here. That's what we were trying to find, actually. So this is going to be a maximum. Go to the left of it. Go to the right of it. All right, so we got -0.56. -0.569, because I'm rounding it up. 569, comma. This is 2.534. 2.534. All right, and so these are actually points, ordered pairs. All right, so the x value is my turning point. -0.569. And that is a relative maximum. 2.534. All right, got one more to do here. Yeah, since this is a degree 4, it actually has 3 turning points this time. All right, they're capable of having that many. They don't all have that many, but this one does. All right, so now I'm to the left of that dip. Now I need to get to the right of that dip. All right, so we got 1.319. That's how far to the right it is. And then, can't really see that. I think it's negative 14.276, looks like. Yeah, if that happens where you can't read it completely, you could just change your window and go further down on the Y minimum. That'll help that. All right, so we got another turning point of 1.319. So we got 3 turning points here, 1, 2, 3. The X value's there. And this is another minimum. All right, another relative minimum, 14.276. All right. Increasing, decreasing. Let's go ahead and do that. All right, I'm just going to read it from left to right here. This thing is decreasing from negative infinity to that X value, which is negative 1.5. Union. It's also decreasing from there to there, which is negative 1.5 to 1.319. I'm actually going to pause and go take care of my dog real quick. All right, thank you for that. So we were talking about decreasing. So negative infinity to negative 1.5. And then I wrote this down wrong. It's decreasing from that X value, which is the negative 569, to 1.319. Now everywhere else this thing is increasing. All right. So between these two X values, from negative 1.5 to this negative 0.569, negative 0.569, and it's also increasing from this X value upwards here. So this X value to the right, which would be 1.319 to infinity. Okay. And then our range. So remember, our range is how far up and down the graph goes. As far as domain, it goes, left forever and to the right forever. And because it's a polynomial, it's always going to do that. But for the range, we just want to find the lowest it ever goes, which is right there. And it's going to be that Y value. So negative 14.276, and it goes upwards forever. All right, from there, that's the lowest it goes, and it goes up forever. So that value to infinity. Now notice I put the brackets this time, and the brackets just means that it includes that number. So at negative 14.276, the graph actually does pass through that Y value, through that point. It actually gets there. But on all these other pieces, in these intervals, this type of interval notation, it was asking about increasing and decreasing. So, at that particular spot, at negative 1.5, all right, you'll notice it's, there and there. It's neither decreasing or increasing at that one X value, at that one number. So that's why we put parentheses around the numbers when we're talking about interval notation. Well, increasing and decreasing, that's what I meant.